This conference will now be recorded.
There you go. Morning all. Welcome to the bi-weekly ACS door heat exchanger meeting. So if I can quickly share my screen, we can go over the agenda for today. Oops, we'll get to that in a bit. So we have a couple of items. First is review what we're calling revision 0.5 of the redfish material for as part of the submission, and then preparing for the OCP for the IC meeting on November 5th. I sent out some slides. I took a stab at putting them together, so we definitely need to go over that. Any adjustments we need to make to the specification document, like the license, which is what Michael Schill brought up previously. I've already set the revision to 0.9, and then updating the material in the contributor portal. And I believe we need to set up a review with the rack and power leads prior to the IC meeting. That's Caleb and Hamid, so that needs to be taken care of. And then quickly talk about the OCP Tech Week. I think review should be back on the drafts, so please have a look at that. We also want to update the wiki with the latest files and documents, and then some other topics based on something that's based on items that have come up during the last 2 weeks. So, so Mike, do you want to get started on the first item?
Sure.
Do you want me to stop sharing so you can do that?
Yeah, it's a lot easier than me describing it.
Sure. Okay. There you go.
And you can see my screen?
Yes.
Okay, so this is a JSON editor that's an extension to Chrome. This is what I've been using to make the OCP profile for the door heat exchanger. On the left is the real text. On the right, it puts it in something that's a little bit easier for humans to understand. So we can open up required profiles. This is a section in here that references other profiles that define things that aren't defined in here. So the OCP base hardware profile pretty much defines everything that we need other than controls. So and we don't have to describe in detail things that have already been described in the base hardware one. So that saves us a lot of time. The chassis control, sensor, and thermal sections that are in here are actually need features that are newer than these redfish definitions that are in the current OCP baseline. So I have to add these in here. So that the chassis 1.15 is a draft version that came out just last week. Actually, sorry, this week, Tuesday this week, from the DMTF, and the controls and sensors and thermal sections have all been updated to do the controls and effectors that we need for the door heat exchanger. Our crew, our software development crew, actually made a schema for the controls based on a presentation that DMTF did a couple of months ago, because we hadn't gotten anything from DMTF, and I wanted to push them a little bit to get us a schema that we could work with. So we kind of crossed paths on that. We got their schema, we sent them our schema. They're going to update their first draft of the schema with some of the things that that we need. to finish this up. So as we've said in the earlier meetings, that all of this is a bit of work in progress, but at least the DMTF has done the chassis and well, done the controls schema so that we don't have to invent our own, which was what our original plan was. So we're kind of a step ahead of where we thought we would be this week. Now these are obviously going to change because it's all a work in progress, but at least it's going to be minor tweaks to this and not major changes. On the resources, the DMTF wants pretty much everything that to be a chassis and other features and stuff to be part of the chassis. So instead of inventing a door heat exchanger or a CDU or something like that, they have definitions for all kinds of different types of chassis. One of their chassis is an enclosure, which is kind of a general purpose box. They also have rack mount, so if we had a rack mount CDU, we could use that also. But enclosure, since a CDU would not be a cabinet per se because it's an odd shape, a rear door heat exchanger is not a cabinet because it bolts to a cabinet. So that their recommendation is to just use enclosure for the type. So our chassis that we're going to have for the door heat exchanger has got a number of properties, chassis type being one of them. And these are the different types of chassis that we could have. Enclosure is the one that I think that we'll typically use, but rack mount would be a rack mount CDU. A sidecar is kind of an odd definition. Standalone could be used as a non-cabinet type enclosure that might be a CDU. So what I'm trying to do is make sure that what we do for work in this one could carry forward for other types of liquid cooling products, including heat sinks or anything like that that we're going to run into, not necessarily just for the door heat exchanger. And the way that this is written here is that none of this is a requirement. We could have this as required in here, and that would force you into implementing this if you implemented any redfish on a door heat exchanger. And I think at this early stage, we don't want to put too many restrictions on how somebody would have to implement the management in a door heat exchanger. So if we could get a few sensors working and not have any controls in a first pass of somebody's door heat exchanger, I think that would be a good accomplishment. And then maybe later on in a newer release of this, we could collectively decide that all door heat exchangers have to implement some of these things, or we don't consider them compliant with the profile. But right now, I think running very relaxed requirements on this is the way to go. Asset tag, I don't think we really care about. So a lot of these other ones in here, manufacturer, model number, part number, and stuff, are just text fields on there. The important one is controls, and this is actually defined by the DMTF now, so we didn't have to use our own. It's not exactly what we need yet, so we already sent comments in against this, and hopefully they'll expand some of the comments, expand some of the fields to get closer to what our requirements are. Some of these other fields that are in here, the names of these are not exactly what we have in the current draft of the requirements for the door heat exchanger in the management chapter that's in there. So in I don't want to hold up submitting it to the IC, but in a future version of that, we should probably spend a little bit of time going through the fields that are already available for a chassis defined by the DMTF, and then potentially update the management chapter in the door heat exchanger requirements to align with what the DMTF already has. And if there's
Right.
fields,
And these are the static definitions, right? Like the header.
yes, yep.
Mhm.
So we could either, leave them as a descriptive field and then maybe put another column in the table that's in there that has the DMTF object that represents that descriptive field, or we could just change them to the field, the names, the object names that DMTF has already done. I wouldn't worry about it with the IC meeting right now. I talked to John Leung about submitting this stuff to the IC, and he said as long as we call the profile that we've done so far a draft and not a released product, the IC won't hold our feet to the fire for making all of this stuff perfect.
All right, excellent.
So in the control, we have a number of fields in here that are exactly what we're looking for. We're looking for a control loop, and this is our PID values that we need to control the behavior of the control loop. We have a control type, and I took the values that were right out of the enclosure spec that we had for the different loop control types and put them in here. So the way that this is written is if you implement this, then the control type value is any of these values, and then these are the possible values on this. And again, this is recommended values. It's recommended that this be readable. It's recommended this be writable. So if somebody doesn't implement the controls, they can still claim compliance to this early draft of the profile. Deadband is otherwise known as hysteresis. Description of whatever the control loop is for. So we could say it's the control loop for fans. Increment is how much of a step change that you would get. So if you're doing like fan control in percent, you might have 1% or 5% or something as the increment for how much you're going to change the value. Location, we might put that it's on the back of the cabinet, or it's in row 5, aisle 2, cabinet 2, or something like that. And you can have a name for it. So it would be, door heat exchanger. You have OEM fields that you can put in here for things that aren't defined yet. Operating mode would be manual or automatic. Physical context lets you associate it with some other managed device, which might be the cabinet itself. So you can say it's attached to the back of the cabinet. And then we get sensors that go along with this. And this actually points to a collection of sensors. So this would be where the water temperature and air temperature sensors go. The set point is the value that we're trying to maintain within this control loop. And then these range min max will tell you how far you can set the set point units, whether it's in degrees C or something like that. And then update time is how often the control loop runs to adjust things. And status is just whether it's actually running or not. We have a collection of controls. We have a minimum of 0 controls in here. So again, so if somebody doesn't implement controls in Redfish, they can still say, yeah, we're doing okay. But this is where you might typically have two controls in here, one for maintaining the fan temperature, fan speed, and one for maintaining water temperature. And then this is the rest of it, just the rest of the static fields that would go along with it. We end up with the chassis also is going to have sensors associated with it. Yep. So we'll end up with this is where all of the
required.
Right, and in the current draft of this, we had said that you have to have an air temperature in and you have to have an air temperature out sensor. So in this case, we've got a minimum count of 2 for the sensors, and the names of the sensors are any of these that are in this. So that's pretty much the only requirement that's in here, is that they implement these 2 sensors. The rest of the stuff that's in here is the manager is the more or less the microcontroller that's running the controls, and DMTF considers that to be a separate piece. So the manager has its own set of requirements that are defined in the baseline document, and that lets us have like the Ethernet interface or a serial console or something like that on there. So yes, we have to have an Ethernet interface in this. We can put a serial console in there if we want, but since the Ethernet interface into the manager is not really part of the controls per se, it might actually be a separate board depending on how you made the door heat exchanger. They consider this to be a separate entity within this. So all of the stuff that is the management device and its network interfaces and everything, I just lifted right out of one of the other OCP profiles. There's a thermal profile in here, and I'm not sure if we want to leave this in here, but this one had a place for putting temperatures, and these are not these are sensor readings, but not directly from a sensor. This is something I need to read up a little bit on, and exactly how and why they're doing this. But this
I think this might be more like I think this might be more like alarming, because it seems to be all about thresholds, right? So
yeah, that may be true. And then they had the same thing for fans in here.
yeah,
And
so
this has got all of these too.
Yeah.
So I think this is probably on interpretation of the sensor readings and associated actions for like you said, alarming and things like that on there. So for now, I think we can leave this in here. So a lot of these have a min count of 2 because we have 2 temperature sensors in here already. And then everything on the left-hand side here is the actual text on it, which is kind of hard to read and understand. So the other part that I'm working on now is a Word document that goes along with this. So we have a Word document that goes along with the profile, and it explains the content of the profile. So this is the same thing. The reference documents in here are all of the documents you need to interpret and understand an OCP profile. The rest of this is the same for all of the other OCP profiles. And this is more or less showing the layout of the objects that are in here. So the service route is where you start with talking to any of the OCP devices. So we have a chassis that's going to represent the rear door cooler, and a manager, which is the management entity for the chassis. And then this has got excerpts. Well, excerpts is a specific meaning. It has pieces of the mock-up, sorry, the profile that are in here, and it kind of explains what all of these pieces are for. So I'm going through this right now, and I'm also doing a mock-up, which is a set of files that you can feed to a web server and have it pretend to be a door heat exchanger. So while I'm working on this document, I'm also working on the mock-up. So these example text fields and stuff that are out of here are coming right out of the mock-up. And I'm not finished with this, so I have to go through and continue to update this. So I'm probably another day or so away from this. But I think the JSON file for the profile is pretty much complete. And then the last piece of this is this mock-up. So I have a little web server running on my laptop locally, and it's feeding JSON files. This is another extension to Chrome that makes it easier to take a look at JSON files. So if we go to the set of chassis that are being managed, then we have two chassis in here, door heat exchanger 0, door heat exchanger 1. I can click on this and say, send that. And you can say, send that. There. So that chassis says it has alarms and controls and a number of static fields in here, and these are all defined by the DMTF. If I look at controls, then I have a fan speed control and a cooling water valve position control. I can click on this and say, and then the control for the fan speed is using 3 different air temperature sensors to decide how to run the fans. And then these are the associated sensors. So these are sensors that are part of the door heat exchanger. If I want to go see what a sensor looks like, I can go look at like return air temperature. Oops, no, I can't. Maybe supply. I had one of these working. There. So that's a supply air temperature sensor. We can change this to inlet temperature or whatever you want to call it. And this has all of the thresholds and how they get activated. So like an upper critical threshold will be crossed when the sensor reading goes above 45 C and the sensor reading is increasing, and the reading has to be above 45 degrees for 5 minutes before it will trip this particular alarm. And we get to associate it with the door heat exchanger. We're sensing this, we're scanning this temperature every 5 seconds. We've got a precision of 1 degree. It's currently 30 degrees C. We can go up to 100 degrees and down to minus 50 degrees, so we can handle Chicago. And that's pretty much it for the work that I've done so far. So I need to continue to do the mock-up and continue to do the Word document that describes the profile.
Yep, sounds good.
And this
Thanks.
has turned out to be considerably more work than I had ever anticipated.
Yeah, I mean, yeah, and I really appreciate, all the effort that you put in, especially since it's not been as straightforward as just reading some documents and making a variant. You've had to reach out to, like you said, PICMIG and DMTF, and had a lot of things moved along. So yeah, really appreciate that.
But I don't want to hold up your IC meeting.
So one last thing on the redfish definitions, Mike, is do you think you could probably put like a one pager or even smaller than that together with regards to, if someone from the IC committee is interested in knowing, it's like, okay, so you are at revision, let's say 0.5 right now.
Yep.
What will it take to kind of elevate this to revision 1.0, and what sort of time frame are you thinking? I was thinking just like a short paragraph or maybe some bullets, right? So that way, if the question does come up, we can always, have that in our back pocket when we are presenting this to the IC.
Okay.
Yeah.
Yeah. Yeah. I have. I'll have to talk to Jeff Autor and ask him when he wants to take the DMTF controls out of the work in progress state and move them to a released state. And that's more or less the gating item for us.
Okay. So do you mind like just putting something short together so we have that in hand when we go
Sure.
for the meeting next week?
Yep, I can do that. I'll send an email off to Jeff and ask him when he's going to finish up this stuff. Yeah, John Leung didn't seem to think there was any problem with leaving this in the draft state for a while.
Yeah, yeah. I'm just, I'm just paranoid like that. So
Yep. Somebody might ask, you want an answer.
yeah. Awesome. Yeah. Thanks, Mike. Really appreciate that. Okay. So let me see. So next up we have the let me share my screen. Next up we have the we have the slides for the IC meeting. Michael Schill, are you back on?
Hey, John. Yep, I'm here.
All right, awesome. So, as we understand, we have a 10 to 15 minute slot, and I wanted to focus just at a high level on sort of what's been worked on, right? So, just sort of give a very, very high level snapshot of the group, the specification, and then obviously the OCP tenets. So. So this is what I have over here. So first, just talking about the OCP contributors. We have Envent and Facebook. Acknowledgements to other contributors who have, helped us in different sections of the spec and, in just general conversation on the content. Then this is the ACS door heat exchanger workstream and what we defined as in-scope activities. So that's been outlined over here just to, and as a result of that, we've looked at the door heat exchanger in terms of different solutions, either the traditional use case, the hybrid use case, or the air assisted use case. And then the specification outlines either guidance or requirements for different areas. So actually over here, Mike, I was thinking maybe we can put like, what do you think about putting like a quick comment on Redfish? Like for example, it's being worked on and will continue to be tracked or something like that, or do you think it?
Yeah, you could put a comment and then point it at the monitor and control, and currently a draft.
Mhm.
It's evolving technology or something.
Okay, so is currently a draft.
Will be updated or something like that. Or,
Okay. Right. So let me just put this somewhere here, and I'm just going to put an arrow, like you said, to monitoring and control. All right. Okay. So this just highlights the different sections. And then finally, we have how the specification, or just this specification complies with OCP tenets. So I took a crack at this, and this is where I really need feedback from Michael, from the two Michaels and Matt. Is so efficiency. Well, the first thing I wanted to call out is the solutions are available for both air-cooled and liquid-ready facilities, which is true. And then the requirements outlined, we have requirements outlined for sizing and efficient operation, like performance and metrology. From scalability, started off with the Redfish standard for monitoring and reporting for seamless and large-scale BMS integration. Mike, is this? I mean, I'm a thermal engineer, so I think maybe I tried to. If I'm selling it too hard, let me know. But is this a reasonable comment?
I think that sounds good. Yep.
Okay. The specification avoids proprietary designs. I believe existing products are compliant and readily available. So I guess maybe I can ask Mike and Matt, but I think it's fair to say that you guys have some products that you guys definitely have some products that comply with the specification, right?
Matt would probably have a better idea on that. We have to make a little adapter frame that goes between the V2 or V3 cabinet and our heat exchanger. And I'm pretty sure we've done a V1 version of that, but I don't know if that's been updated to the V2 or the V3 cabinet yet.
I think we actually did a V2, but that's not, that is literally an hour of work to modify that to suit. And yeah, John, I actually think for the air assisted liquid cooling, we're going to have that adapter frame done for a V3 because we have the rack drawing now. So that's easily done. So yeah, and that should be fairly standard in how the spec is set out. It mentions that an adapter frame can be used and calls that specifically out. So for most vendors out there, from a vendor neutral position, that shouldn't be a big work item. And the door is what is potentially proprietary, but the interconnection with that adapter frame makes it interoperable.
Right. Yeah. So so the adapter frame aside, right? I mean, if we set that aside, and like you said, it's called out in the spec. The actual door heat exchanger assembly, at least with regards to the high level requirements that are, well, not the requirements that are outlined in the spec, I would assume that they are, in a sense, they are compliant, right?
Yes.
Okay. Cool. Yeah, because I wanted to check that over here because that might be.
And that's again a yes from what exists on the market. That's a yes. 600 mil is a standard width. The 45 degree that enables at least 90 degree plus opening. That every door that I'm aware of on the market, it would be compliant to that.
Okay. And then the last bullet point I have is facility requirements are clearly outlined. So, you know, the air side boundary conditions and the water side requirements. In terms of openness, I basically called it marrying available door heat exchanger products. Exactly the point that we were talking about, right? Is that they're off-the-shelf products that potentially could be married with with an open rack architecture, right? Whether it's
Yep.
V2 or V3. And then harmonized requirements across partner streams, and then collaboration across members, attendees of ACS door heat exchanger subproject. And impact, I've added, it includes guidance for vendors, integrators, and end users. And we have definitions, requirements that can be employed to compare products from different perspectives. So the performance and metrology section, where you can say, hey, can you use what's defined in the OCP spec and tell me what your numbers are? And then, people can, end users can potentially use that as reference to compare different designs if need be.
Yep. I think the biggest, just as a side note, nothing that needs to be added to that. The biggest, I think, challenge on that is going to be the sensor side of things, and it's not so much the software implementation of the sensors, but comparing the location of the sensors and how many sensors a vendor may put in it doesn't explicitly state in the spec X number of sensors in these locations. So, that's where the comparison gets a bit muddy, but from performance and the way the spec is written, performance points, dimensions, size, function, it's there.
Yeah, I think not highlighting the number of sensors, I think is by design, is because you ask different vendors, they're like, oh, 2 is more than enough. You can also ask an end user, right? I mean, some of them might be like, oh, why can't we have 3, right? Like a top, middle, and a bottom. So yeah, it just depends. And that's why we're like, you know what? We let the end user and the vendor sort of work that out together, in terms of how many sensors they'd like to. Because I'm sure a vendor would be happy to put as many sensors as the customer desires. So yeah. Is that fair to say?
Yes. Yep.
Okay. Okay, and then yeah, it's basically, yeah, the intention is to keep it short because we only have Michael Phil, I think we only have 15 minutes, right? And that includes Q&A. So it's like just
Correct.
keep a simple message. So
And John, just to go back to the tenant slide there, the only thing that I would say is I would be prepared to maybe back up some of the efficiency claims with some actual numbers if they're available, or any projections. I think that's the only one of those 4 where the IC might actually ask for some evidence there.
okay. Okay, so okay, yeah, I can work offline with with the rest of the authors and fill that out. Yeah. Okay. Any other comments or suggestions for the IC meeting slides?
Well, another point on your efficiency is floor space, because the power density on all of the servers is going higher and higher, and eventually they're going to reach a point where you can't air cool it anymore, and they're going to have to go to a hybrid solution or a complete liquid solution.
Okay. So you would call that, I guess,
Reduces floor space potentially, because you can,
Yeah, from the rear door perspective, it enables higher rack densities.
okay, higher rack densities. And I guess we can say
reduces floor space.
Yeah, reduces floor space. Yeah.
Yep.
Okay. Yeah. So then
I mean, if you, to Michael's comment, if you wanted a, numbers in there, we all know it's either the 40x or the 100x, improvement in removing heat with liquid than with air. It's that statement of close coupled cooling where your guys with the fan wall technology have a very long air path to get that back, and by removing that heat right there, it's an efficiency statement, operating efficiency statement from the data center perspective of it's about 40x efficiency improvement versus removing that heat over a long air path with air.
Right. Okay. Yeah. I'll definitely reach out to you guys to make that backup slide. I think it might be good to also show, right? Oh, standard door heat exchangers can, support about, let's say, here's a standard door heat exchanger, right? It's capable of supporting, like, let's say 40 kilowatts, right? But that's 40 kilowatts of bringing the air back down to inlet conditions. And if it's a hybrid system, it could be so much higher than that, right? Depending on what's the split between air and liquid cooling. So yeah.
Correct. And the other way we've always looked at rear doors as well is the 100% removal, bringing it back down to inlet is one thing, and that's you're like 40 kilowatt. The other flip side of looking at is taking an 80 kilowatt rack and making it look like 28. So there's an exponential gain up to a certain point with that. You may not be bringing it fully back to ambient, but if your data center could handle, a 28 kilowatt heat load and you wanted to put a 60 kilowatt heat load within the rack, you're taking that delta out with the rear door and allowing the normal data center air side to function, within its limits. So, I mean, you can pump that either way. You could pump that, well, that's a floor space because now you don't have rack sprawl, you have higher rack densities. Yeah, that story just goes that way. At IBM, we always used to say, well, I can, this is back in the day, 10, 15 years ago, I can make a 20 kilowatt rack look like a 4 kilowatt rack if that's what your data center cooling limitation is per rack.
Right. Okay, excellent. So I'll be reaching out to you guys for help with that backup slide. Let me see. Michael, along with these slides, I also sent you a revision 0.9 of the spec. I think we just need help in adjusting the license block, I guess, if you want to call it that.
Yeah. So I was looking at this morning.
Is that something that you can help us with? Because
Yeah.
I'm not entirely sure how that needs to be adjusted.
Yeah. Do you want to go ahead and pull it up now, and we can walk through it real quickly?
Sure. Let me. Okay. So. Okay, let me share my screen again. Can you guys see my screen?
We can.
All right.
So the license section now.
Yeah. So I'm just saying adjusted to revision 0.9. And before we get, I've also given it a date because I think the last time we made a change to this document was back in August. But I'm just going to call this. Actually, I'm not going to say first publication. I'm going to say. But what we're just going to say draft for review. I'm just going to say draft for IC review, and we can change that. But yeah. So we are at the license section.
Yeah. So you can go ahead and delete that bullet point there. It needs to be updated because that's what we'll do right now. And then in that first paragraph, since the subgroup isn't who signed the agreements, it was Invent and Facebook. We need to list Invent and Facebook at the end there after that colon after by in the first paragraph.
Sorry, what do I?
So that first sentence there, where contributions to this specification are made under the terms and conditions, et cetera, et cetera.
Oh, okay, I see.
Yep.
Okay.
'Cause
Yeah, and then just say Facebook and Invent.
Yep. Absolutely. And then
Is that the right way of writing Invent, by the way? Matt, Mike, is that correct?
Yes, we explain that to every single customer we have many times.
Okay.
And
then
how to pronounce it.
Oh, did I get it wrong? Should it be Invent?
Invent.
Invent. Okay, got it. Noted.
Nobody
we
gets it
want it
right.
to be different.
Yeah.
Great. And then John, the only other thing in this license section, everything else looks correct, is you've just got a grammatical error there in the last sentence. We got an extra space between. Yeah, right. And that was the only thing that I saw when I was looking through the specification that you sent over yesterday. The rest of the draft looks fine. The acknowledgement section isn't something that we see a lot of, but we've had it be added before, and it hasn't been an issue.
Yeah, I mean, I definitely want to add this in here because the reason why the authors are Facebook and Invent is because there have been like significant contributions to moving the specification along, and the people we have. I mean, we have Matt in the backup, but it's about acknowledging who else sort of helped move the specification along as well. So yeah, definitely do want to leave anyone out, anyone significant. Yeah.
Great. Yeah, and like I said, that's all I saw. Everything else looks great. So if you want to send me over this latest version, and then
Yeah, maybe.
Yeah,
And then maybe you can help me remove this yellow highlight for some reason is now moved up to the bullet point.
Yeah, I think if you just go ahead and highlight it with your cursor. Can you do that?
Yeah, I'm trying to. It's not letting me. I'll send it over.
Yeah, send it over. I'm happy to take it off. And then John, I'll go ahead and upload it in the portal, and we should be good.
All right, awesome. So actually, really quick, since I have Mike on the call, Mike, do you want to? We have a line in here at the end of the monitoring and control section that says, I'm just going to change this from schema to profile because I think that's the term that OCP uses. So I'm going to say redfish and and redfish is not written the right way. I need to put the registered trademark the first time it comes up. Redfish profile and reference documentation are currently TBD. Do you want to leave that as is?
WIP is what the DMTF use, a work in progress.
Okay, awesome. And I need to find the first time we refer to redfish, and yes, and I've been using the wrong. Yes, I just need to put a registered trademark over here, but I'm on my Mac right now and I have no idea how to do that. On the PC, I know how to do it. The quick
insert symbol. If you're just using Word, it's an insert symbol.
Oh yes. Yeah, I can take care of that. Let's. I'll do it offline. Okay, good. So the two changes I wanted to make are good. So Michael Schill, I'll send this around off to you after the meeting. The other thing we need to touch on is stop sharing. Is setting up the review meeting with the rack and power leads. I think that needs to happen before the IC meeting, right? So I was thinking I'll set something up with Hamid and Caleb probably Monday, and then just make sure that that Mike and Jacob and Stefan are on that as well. So is that something that you can help set up so we can use GoToMeeting or?
Yeah. So John, typically the project leads just log into the portal and they review the specification and submission that way. If you feel like you'd rather have a call, then I'm happy to set it up. But generally they just review it in the portal. They have a login to go in and take a look at everything. But yeah, totally up to you. If you feel like you'd rather have a call, then I'm happy to facilitate that.
Well, I mean, I was assuming that we needed to have a call. That's why I was asking. If we don't need to, and this stuff goes into the submission portal, yeah, then they can go ahead and yeah, I'll send it over to you. Yeah, I'm fine with that then. We don't need to have a separate.
Yeah, perfect. Once I get these final versions over there, I'll just start an email thread with everyone and just let the project leads know that it's in the portal. They can go look at it, and you guys will be on if there's any questions.
Yeah, I guess the only two files, the only files that need to go in, I guess maybe Mike, you can put in the profile for now, and then maybe share the human readable document. What was the other one? The mock-up, and I think the short description. I think that can maybe go in next week or whenever you're ready.
Yep, I can do that.
Okay, very quickly, I know we're over, but I need to touch on two more items, so I apologize. One is the OCP Tech Week feedback for review should already be available, so FYI. With regards to the OCP Tech Week, I guess Michael Schill, if once we have the latest files for the IC review meeting, after that, if you can go and update the wiki with these latest documents. So that way, when Mike Thompson is presenting about redfish for cooling, people can go to the wiki and click on the files, and then basically reference a lot of the dough heat exchanger stuff that Mike's been driving based on that. So that would be great.
Yeah, happy to.
And one last question I had, and this is something that came up in discussion with the other ACS leagues, and I guess this is a question for Matt, so it's good that he's on the call. So Matt, if you think about a dough heat exchanger, right, what would you consider as, when you think about water supply temperature, what would you consider as a nominal range and then an extreme value?
Nominal range, I would probably say 16 to 20, probably 26. I think 26, 27 is a 27 actually. Let's make it 27 because that sort of jives with ASHRAE A3 and W2.
Okay.
So I think that's a good range that allows for direct facility connection. I have used them warmer than that before, but as you're aware, the warmer you go, the less capacity you're getting out of it. I think the extreme ranges would probably be on the low side 12, and probably on the high side about 35. That puts you right up into the 40 is A4, and you want to have some sort of delta. So if you're 35, that gives you a 5-degree delta T rise on your water. So your output should be somewhere in that 35 to 40 range, depending on capacity, flow, and all that nonsense.
Right. And if we talk about like capacity and everything aside, what's the maximum water temperature that the door can maybe withstand more from like a chemical or like a compatibility standpoint? Then you would say that that could be pretty high, right?
Oh yeah, that'd be pretty high. I wouldn't even know what maximum that would be. I mean, that stuff there is just like a regular water system. I mean, some of these hybrid systems can do like 45, 50, 55
Oh,
like even
hybrid.
higher than that.
Yeah,
Yeah.
easily. Yeah. Yeah.
I would say probably like we've been specking a lot of our stuff up to 70. So I would say 70 would be the absolute max that they can withstand.
Okay. So spec up to 70. This is awesome. Yeah. Thanks for that information.
Yep.
Yeah, but I agree, right? With hybrid, I mean, it's kind of the opposite of the traditional use case, right? Is you want that return, the temperature of the water returning to the heat exchanger to be as high as possible to maximize
Yep.
the amount of heat transfer. So yeah.
And yeah, I mean, and that, that's based off of where we're at, like sort of today and yesteryear, T case of 79. You obviously don't want to return 79. You want some form of a buffer, but 70 seems to be about it. A lot of the people now, and the hotter the chips are coming out in the future, those T cases are actually, they're increasing, but everybody wants to decrease their water and be returned 62. They just want a bigger buffer between T case and or between water return and T case, just if there's a flow issue or something like that, momentary stop. So, and then the other half of that, there's a few chip vendors out there that they're actually lowering their T case, just for there's so much power going into such a small space. I've seen T cases down at 72, at 71, and a 65 return temperature. That's 5 or 6. You can blow through that with stagnant water real quick. So, yeah, I think 70 is a good sort of line in the sand.
Okay.
And this is where you open it up to the community and you solicit that feedback. But I think for where we're at and the applications therein on the horizontal scale, 70 is a good maximum to just sort of put out there.
Okay. Awesome. Yeah. I'll go ahead and yeah, this is a good reference point. Yeah, I might follow up with a question to the community and see, who else has thoughts on this. Thanks.
Yep.
All right. I think that covers all the items that I had on the agenda. I mean, we had one about ORV3 and mounting it with the blind manifolds, but I think on that one, I'll probably need some, some initial information from Stefan, so we can probably follow up on that one during a proceeding call. Right.
Sounds good.
All right. Thanks all.
Cool. Thank
And
you.
see you next week for the IC
We'll see you.
review meeting. See you. Thank you.
Yep.
Right.